Welcome. My name is Rahul Tiwari, and today I'm going to be talking about the results of the Smart Backpack project. As you saw in my last video, I performed a presentation on the logical flows that the decision subsystem goes through in order to make decisions for the user. Today I'm going to be talking about the results of my project. Now, as you can see here, I have a series of components and modules on my table here. Over here, this is the backpack module. This is a completely self-contained unit in a relatively small package size, all powered by a 9-volt battery, and it contains an RFID tag, a GPS-B GPS unit, and an XB. The XB will communicate with PAN to my decision subsystem, as you can see here. This decision subsystem is housed on a Raspberry Pi inside of a case, hooked up to an XB Pro and a Wi-Fi module directly underneath the XB Pro on the secondary USB port, and it's also hooked up to a TFT display which acts as a console to provide me with experimental and engineering testing data. Now, as you can see over here in the back, I have a similar device to the backpack module, which I call the locker module. The locker module is similar to the backpack module in that it's housed on top of an Arduino in the same configuration with the same board. However, as you can see here, the GPS unit is not placed on the board, but rather it is depopulated. But it still remains on the same board. The locker module has a fixed location, so a use of a GPS unit would not be necessary. Therefore, there was no need to place a GPS unit on a board, similar to the backpack unit. Now, my decision subsystem makes decisions based on inputs from my backpack module. My backpack module takes inputs from books inside of the backpack. Right here is a history book. This history book has an RFID tag on it that basically is read by the RFID tag sensor and then is communicated to the Raspberry Pi, similar to my mathematics book, which also houses an RFID tag. Now, in order to demonstrate to you the results of my experiment, I need to place these books inside of my backpack. And to do so, I need to put the RFID tag on the RFID tag sensor and determine whether the backpack module sends data to the Raspberry Pi, which houses the decision subsystem, and the decision subsystem should send a message to me, the user, on my user interface, which is my phone, my cell phone, in the form of a text message. Now, the demonstration for the first test case will be an incomplete backpack. A student will be going home, I'll be going home as a student from school at around 4 o'clock on a Tuesday, which means on Wednesday I need my history and math book. And I'll only place my history book and completely forget about my math book. So I'm going to go ahead and place my history book inside of my backpack, and as you can see from the console window, the decision subsystem has registered an event that the history book was added to the backpack and it has been transmitted. Now, as you can see, it's performing decision-making tasks throughout a certain time period. And then it makes a decision. As you can see here, it says message sent and what the bag contains. And as I open up my cell phone, I find that there's a timely response in the form of a text message sent to me that says that my backpack is incompletely packed because I forgot about my math book. So now that the decision subsystem has reminded me, I'm going to go ahead and place my math book onto the RFID tag sensor, and then the decision subsystem will realize that there is an extra book added to the entire system and will send me an appropriate message. As you can see, it says here that the backpack contains a history and math book, and it sends me another message that says that the backpack is completely packed. Now, the decision subsystem will perform all of these functions, including what's displayed on the console window, completely without user input. As you can see, there are absolutely no connections between this, the backpack module, and the decision subsystem. The decision subsystem can be centralized and placed in a unit completely separate from the backpack module. The user will never see the decision subsystem and see what the decision subsystem is doing at any given point in time. However, the user will know, the student will know, that the backpack has intelligence to give it information on whether their backpack is completely packed, incompletely packed, or overpacked. Now, another test case that I decided to implement was the overpacked scenario. So in order to perform this, I have to go ahead and place an extra unit inside of my backpack.